Okay, students, we are diving into lesson 2.3 on composite and inverse functions. This is pretty much a continuation of what we've been doing and just now using composition to prove inverses. So if you look in this first block, the composition of the function f with g is just reminding us that f and a little circle is being drawn, and then g. The function notation is the same as when you use parentheses. So please note that we are going to use these two notations interchangeably. They both mean the same thing, and keep practice reading it as f of g of x, and you are merely substituting expressions into other functions instead of just numbers. Okay, so what I'll have you do is follow along here with me for a second. Let us go review a little bit and warm up with composition. So in example 1, I give you f of x equals 5x plus 2, and I give you g of x equals 3x minus 4. So first of all, let us focus on doing f of g of x. So I'm going to come over here and write that out. So it's f of g of x, which means that I am going to look at my f function and I am going to replace every x with the g of x function, because what's inside is what I'm substituting with, okay? So I'm going to look at my f function, which begins with 5. So I start with 5, and then this x right here is going to disappear. Okay, so literally I'm going to make it disappear, and I'm going to replace it with my g function. Let me put it there. So 3x minus 4. And then after that x, there was a plus 2. Okay, so instead of 5x plus 2, I'm rewriting it in terms of g of x. So it's 5 times 3x minus 4 plus 2. Now you will just simplify. So distribute that 5. And then negative 20 plus 2 are like terms. So 15x, minus 18. We are going to practice one more time. Do g of f of x. So now in this case, you are looking at your g function. Okay, we're going to look at our g function. So our g function in this case now starts with a 3. And then as soon as you see the x, okay, in that g of x function, so that x is going to disappear. I'm coloring it out with my yellow because I need to replace it right here with the other function, which in this case is 5x plus 2. Okay, and after the 3x, there was a minus 4. And I'm going to distribute, and I will combine like terms, and this is my final answer. Okay. So now that we've warmed up, this is what you pretty much did in section 2.2, the lesson just before this. We are going to use what we've learned in applying composition to work with inverse functions. So here's what I want to draw your attention to. You are going to be given two different functions, and I need you to prove that they are inverses of one another. And in order to be able to do that, what you'll need to do is take the composition of the functions in both directions, okay? I don't care which one you do first, but you are doing f of g, and then you're doing g of f, if that's the name of your functions, okay? So here in example 2, we are given f of x equals 6x, and g of x equals x over 6. So let's do f of g of x, okay? So f of g of x, it doesn't matter which one I'm doing first, by the way. So f of g of x says that I need to look at my f function first, okay? So I'm going to go look at my f function, and I need to erase all the x's. So this x right here in my f function, I'm going to make it disappear because I need to replace it with the other function. So 6, erase the x, and replace it with the other function, which in this case was x minus 6. Now when I multiply 6 times x minus 6, the 6's are going to disappear, they cancel, and I get an x. This makes me super happy because so far it is meeting what I talked to you over here about upstairs, that our composition needs to always equal x. So that worked out here. Check mark. Let's go and do the next one. We need to go in the opposite direction. They're telling us to look at the g function, and now for every x, replace it with f of x. So let's go to my g function. I'm going to erase my eraser here. I'm looking at the g function, and I'm going to erase every x that's in my g function. So wherever you see that pink, I need to replace it with the other function. So that pink needs to be replaced with 6x. And then there was a 6 right underneath it. Okay? And when I do my math, 6 divided by 6 is 1. I get an x. I am happy. So, what does that conclude? F and G are indeed inverses of one another. Okay? So it always has to equal x. Okay? So, moving on. Let's do this one. I will have you pause the video and then come back and check your work against what I did. Alrighty, so you are back. Let's see how you did. So verifying the function are inverses of one another using composition. So we're going to start with f of g of x. So f of g of x. I need to look at my f, and get rid of all the x's. So I'm getting rid of all the x's, but in that yellow spot, I need to put something in that yellow spot, okay? There's something I need to put in this yellow spot where I deleted. So I need to put the other function in that spot, okay? So I'm going to go take the other function, g of x, and put it in here, in that yellow spot. Always with parentheses, by the way. Anytime you guys substitute, use parentheses. After my yellow, there's a +9. Okay? So now you are just going to, sorry, I have to erase here, and it's not erasing for some reason. There we go. So now we are going to simplify. This 4 and this 4 are going to cancel to become 1. So now I'm left with x minus 9 plus 9. And we all know that negative 9 plus 9 is just 0. So you get an x. That's good news. So now we do g of f of x. So now we're looking at the g function, okay? So if I'm looking at the g function, I am going to ignore all the x's on the g function. So in this case, looking at the g function, I only have one spot. So this yellow spot here, I'm going to replace it with the other function. So in that yellow, I'm going to put 4x plus 9. Okay, actually, I should have written, hold on a second, because for some reason, let's put the yellow spot here so you can visually see the connection. So in that yellow spot, we put 4x plus 9. But after that yellow spot upstairs here, there's a minus 9. So I'm going to put a minus 9. And then all of it under 4. So it should start cleaning up. We recognize that 9 and negative 9 are going to become 0. So I have 4x over 4, which simplifies to x. We got our x's. We have proven that f and g are inverses. Very, very simple. Okay? So if you get something, anything other than x, they are not inverses of one another. Okay? But just a heads up, in our homework practice, all of them are inverses of one another. Okay, let's find the inverse of f of x equals 6x plus 3. So above you're going to see some pointers, steps as to how to proceed. The first step tells us that we need to replace every f of x with a y. So any function notation, let's rewrite it with y. So instead of f of x equals 6x plus 3, for step number 1, I'm going to write y equals 6x plus 3. Okay. Then next, step number 2. So let me put step number 2 here. We are asked to interchange x and y. So wherever you see a y, make it an x. Wherever you see an x, make it a y. So that's step number 2. Okay. Step number 3. We are going to need to solve for y. We want to isolate y in our equation. So right now, the y that we want to isolate is this right here. It needs to be all by itself on one side. So that means ideally, in order to get y to be all by itself, I need to get rid of this 6, and I need to get rid of this positive 3, and I'll be happy, okay? So how do I get rid of those two numbers? Well, you first need to get rid of the 3. You're going to get rid of that 3 by subtracting 3 on both sides, because then it will zero out. So we have, this is step number 3, by the way. We have x minus 3. Those are not like terms, so we can't put them together, so to speak. We can't simplify any further. And then 6y, and the 3 plus and negative zero out. So I'm almost done. I need to get rid of the 6 next to the y, which means I will divide by 6 on both sides. That causes the 6 to cancel out because it becomes a 1. So y equals x minus 3 over 6 is my almost answer. Why? Because I want to have you show me function notation. By the way, in step number 4, where I say, show that the answer you got, if you compose the answer you got with the original equation, show that it equals x. This is the fourth step to check your work. I'm not going to do that because we already did it a couple of times. But as far as fourth steps is concerned, wrap it up by making sure your final answer is in function notation. You have found the inverse, so say function inverse, f inverse of x is equal to x minus 3 over 6. That would be my final answer of my inverse. Okay? So if I were to compose those two in both directions, they would both equal x. Okay? So let's practice I think it's 2 more. Yeah, here we go. So let's do this first. The f of x becomes a y. And everything else comes down. And then we switch the x and the y. So y becomes x, and x becomes y. That's step number 2. Okay, so here now, highlighting again, I need to get rid of the 1, and I need to get rid of the 3. So which one am I going to get rid of? Now, if you were first saying minus 1, you don't want to do minus 1 because it's still trapped inside the parentheses, okay? you are going to get rid of the third power. The third power goes to the other side and becomes x to the 1/3 power. Or you can also write it as a cube root, by the way. If you want to write it as x to the 1/3 or x, I'm going to put both of them just in case, or x cube rooted, both of those are correct. Okay, the opposite to an exponent is a root. So if it's to the 4th power, like x to the 4th power, the opposite to that is the 4th root of x. Okay, or x to the 1/4, whichever one. These two are the same. I hope that makes sense to you, okay? So whether you use the top one or the bottom one right here, that's going to equal y plus 1, okay? And I'm going to, because I need the space, let me put it over here in green. I'm going to put this just in case one of you decided to use this instead. You can use this there if you want. So I'm going to put or. Okay? All right. So if you're using the green one in radical form or the one with the fraction exponent, it doesn't matter. What are you going to do next? Well, I'm going to subtract 1 on both sides. So my final answer is going to be x to the 1/3 or cube root of x equals, oh, forgot my minus 1 because I subtracted 1 on both sides, equals y. These here disappeared. They canceled. Okay, so now that I have it written in terms of y, I'm going to write my final answer in function notation because my problem was given to me in function notation. So I write down the letter of my function and I put a little -1 here that looks like an exponent, but it's not, okay? Don't confuse it with reciprocals. All right, so x, oh, my pen's getting trouble. X to the 1/3 minus 1, or if you had written it as x cube rooted minus 1, they both are correct answers. Okay, so whether you write it in notation such that, okay, I was trying to select, but it's not going to happen. Hold on a second. I'm going to try that again. I'm trying to be fancy, but it's not. Look how it's not working. So whether you have that one or you have this, this other one right over here. Can I do this? I can do this. Those are horrible. I'm playing around now instead of focusing. Okay, so whether you write it as x to the 1/3 minus 1 or cube root of x minus 1, both of those answers are correct, okay? So know that these two forms are acceptable. All right, here we go. Example number 6. We're almost done, folks. So let's change the f of x to y. And then I switch the x value and y value, interchange. Okay. And then I am going to solve for y, so I need to get rid of this 3 and this minus 4. So I need to get rid of those. The first thing you want to do is get rid of the minus 4. Okay, that's furthest from the y. So that becomes x plus 4 equals y to the 3rd power. But now I need to get rid of this power, okay? So that power needs to go to the other side. It needs to jump over the equal sign and go to the other side. So how do you do that? So just like we did upstairs, the 3 pops over and becomes a 1/3. So now you have x plus 4 to the 1/3 equals to y. And that's your answer. Okay. All right, my dears, let's go on over here. So the horizontal line test, you guys have actually, already done this in Unit 1, okay? So this is just a refresher. So if I asked you the following, is the graph that you're looking at, right? Is the graph a function? When I asked that question to you all, you guys applied the applied the vertical line test to be able to tell me yes or no. And so when you look at this first graph in part A, does it pass the vertical line test? Basically what I'm asking you, is this graph a function? And we notice that it is a function because every single time we drew a vertical line, it touched once every single time, okay? So as far as, is this graph a function? I'm going to say yes. F of x is a function, okay? And that's because it's been applied the vertical line test. Now, if you are asking another question, is the inverse of this, is the inverse of the graph, okay? I was debating if to use the word function or graph, but is the inverse of this graph, which is a function, I guess you should put, because I'll tell you why in a second, which is a function. I guess this question is going to be really complicated if I write it the way I did. Okay, wait. Is the inverse of the graph a function? I'm going to keep it simple. I don't want to confuse you. All right, is the inverse of the graph a function? Okay, when you're asking that question, you are going to apply the horizontal line test. So let's look at these examples on the left. We know it passed the vertical line test, so it is a function. But now I want to determine, is the inverse a function? Okay, so I'm going to draw horizontal lines this time. Touched once, touch once, touch once, once. So notice every single time this horizontal line touched that graph once. So what does that mean for us? It means the following. It means that, yes, the inverse, this is how you write, oof, you're not going to be able to see that really well. So what you do is you draw an F and you put like in the exponent area, put a -1 of x. So what it reads is, yes, F inverse of x, and it passed the horizontal line test, so we'll say is a function. Okay. Likewise, if we look at the bottom function, we try the vertical line test. Every single time it touched once. So we are going to say here, yes, graph is a function. But if we look at it now with the horizontal, notice that your purple lines are intersecting the graph more than once. So what does that answer? What does the horizontal line test answer? You would say no. The inverse graph isn't a function. Okay. So those are the two tests. If it passes the horizontal line test, by the way, it means your function is 1-to-1. And we arrived to the last example. So I am going to be giving you a picture of a graph, and you have to be able to plot its inverse, okay? So it's a very simple task. Watch the above rectangles. All you have to do is reverse the coordinates, okay? Looking for a different color here. All you have to do is reverse the coordinates of the points on the graph that is being given to you. And then you will proceed to plotting those points. So for instance, -2, 0 would become 0, -2. 0, 1 would become 1, 0. And 1, 3 would be 3, 1. Okay, so you'll either take them from the table and switch them, or if you don't have a table, just pick points and switch them, which is what you will do on Delta Math, by the way. Okay, so I'm going to graph these points that we just pulled. So 0, -2. Okay, I don't have enough space. What am I doing here? So I'm pretend 0, -2 is like about, it's going to be hard. Can you see that? I'm trying to make it, there you go. 1, 0 is right here. And then we have 3, 1. 3, 1, which is around right here. Okay. So what I want you to realize is when you connect these, that's not right. I lifted my pen. Hold on. There we go. When you draw the connection between these points, I'm hoping that at this point you're noticing that your graph are mirror images over this y = x line right here. Okay, this is the y = x line. Inverse graphs reflect over this y = x line. Okay, so literally you can fold your paper on that equation of the line, which is y = x, and this orange or orange like purplish graph will become this one and flip over that line. So in reality, we probably should have made a dash line of that y = x line. But that's it. That's it. I hope this lesson is not too bad and that you understand it. Thanks for watching.